When we think about ways to organize data coming from contracts, it's very understandable and natural to want to group related or similar information together. Very commonly, this is done using clustering in a lot of contracts related products. Now, this can happen at two levels. This can happen at the provision level, where we want to group provisions together or clauses together that are similar. So ideally, if we have multiple variants of change of control, we would like all of variant A in one group, we would like all of variant B in another group, and all of variant C in another group. This can be a very effective use of provision level clustering because it might allow us to tell us if there are particularly problematic cases or everything is kind of following the same form and we might need to deal with some outliers that have slight differences. The other way to benefit from this is that we can use this to potentially automatically identify clauses similar to those we've already identified. So this can bootstrap, in some sense, a training system to do content extraction, because by identifying a change of control clause, you can use clustering to go identify all clauses that look like this, group them together, and then potentially presumptively label them as change of control. The problem with this, of course, is that this can be a little permissive in that it depends on how similarity is defined. But it can also be tricky depending on how the clustering algorithm itself actually works, where it might have some predefined numbers of clusters that it has to produce, or it might be either too coarse or too granular, and you get very distinct or overly general clusters, which, depending on how you're trying to use it, may be problematic. Now, of course, one of the other very interesting things that you can use with provision level clustering is if you have multiple predetermined machine learning models that will pull out different types of clauses, change of control, assignment, exclusivity. You can use these different clusters that come out for these different machine learning models to also then cluster documents, because then you can have documents that have change of control variant A, exclusivity variant B, and maybe most favored nation variant C in one group and other combinations in other groups. This can help you identify much more related documents based upon the information you care about. But even more generally, document clustering deals with the idea of grouping related documents together based upon their interior contents, not just one or two clauses, but potentially the entire document. Now, very commonly, this can be used to bootstrap a document type classification system, which is probably the most ideal case for using this type of clustering. But you can also do it to try and identify documents based on the same form or with very similar templated language or structure. Now, of course, with any type of clustering, you have to really understand how the clustering actually works to get the most out of it, which is the downside to clustering. Unfortunately, there is no one-size-fits-all clustering, and depending on how it's written and how it's coded by your software vendor, you're going to potentially get different results depending on what they assumed your use case was going to be. And so if they had assumed that there will be at most 10 clusters and at least 5, then in any set of documents or provisions you might provide to that clustering algorithm, you're going to get at least 5 clusters and at most 10, which may or may not be beneficial. Again, this goes into the trade-off between the coarseness and the granularity of the resulting clusters that get produced. And that's where things get tricky. If you can't tailor this to your use case, clustering becomes less and less useful. At least that's been our experience. Now, this isn't to say, again, clustering isn't useful. It just requires careful consideration when and how you're going to apply it. Because again, you kind of have to introspect all of these clusters that get produced to really understand what's in them. While you can try and use sampling to understand this, again, it's dependent on how similarity is defined, dictates what's in a cluster. And so while you might get lucky and pick a couple things that look like what you expect to be there, there could be many other things that look differently that you don't expect to be there. The other thing to keep in mind is that clustering itself is really just a mechanism to do something else. You want it to produce these groups so you can do additional review. And that's the core focus of a lot of this stuff, is how does clustering optimize the review task or the training task down the road? And again, if it's going to produce groups that aren't useful for you, then maybe reevaluate whether that clustering solution is right for you. There might be one that is right for you, but not any arbitrary one is going to be right for you. please do take the time to investigate the different pieces of clustering technology available to you, find the one that's right, rather than relying on whatever a vendor might tell you, because it saves you time and ideally money.